All right, so everybody, welcome to the first of many Math 2 lectures for the semester. For those of y'all that don't know, I'm only Miss Cecily's director. So to Eve and Kyla, my name's Mr. Julian. I'm the director of Mathnasium and Briar Creek.
Nice to meet you.
Yeah, nice to meet you too. All right. This is Math 2, Lecture 1. We're going to be talking about congruent triangles. All right. So again, because I'm Cecily's tutor, I know that she's already talked. She was talking about this in school before Corona hit. What about you two? Have y'all already talked about this in school yet?
I took Math 2 last year, and Miss Emily, the director of the Mathnasium I go to, said I was allowed to come to the Math 2 ones.
Yeah, anyone's welcome.
Didn't really understand a lot last year. I do remember that there are things that just congruent triangles, but I forget what they are exactly.
Yeah, no worries. What about you, Eve?
Yeah, we did this.
Okay. Okay, so this should be a review for everybody, but I'm still going to go back to the beginning to make sure that we're all on the same page. All right, so to start off, can anyone tell me what does congruence mean? Anybody have any ideas?
Equal?
Congruence, like what in general, like what does it mean if I say that two things are congruent?
The same.
Yeah, exactly. Specifically in geometry, it means that I'm saying that two things are the same size and the same shape. All right. So specifically when we're talking about triangles, there are a few different ways that we can prove that two triangles are congruent. Or I should say 5 theorems that y'all learned in school to prove that two triangles are congruent. Does anybody remember what any of those theorems are? All right, I'll get us started. The first one of them is side, side, side.
Oh, ASA.
There you go. Good. All right, can someone give me another one?
Angle, side?
Yeah, good. Angle, angle, side. All right, so we got 3 of them. What else?
Side, angle, side.
Perfect. All right, and then there's the last one, which we don't use as much, but it's specifically for right triangles. Does anyone remember what that one is?
HL.
Perfect. All right, look at y'all. Good work. All right, so let's go into detail, talk about what each of these mean. All right. So side, side, side. I have 2 triangles, and all 3 sides of both triangles are the same length, which I can indicate using the stick marks, right? All right. If I had side, angle, side, that means that I have 2 triangles. And 2 sides on the triangles are congruent. And also an angle in between the 2 sides is congruent too. So that's side, angle, side. There's also angle, side, angle, where I have 2 angles. let's try this one more time. Two angles. And a side in between them that's congruent. Angle side is when I have two angles and a side that's not between them. It could be either of the sides that aren't between the two angles that's congruent. And last but not least, hypotenuse leg, which is when I have two specifically right triangles. And both the hypotenuses of those triangles are congruent. And one of the legs of those triangles is congruent too. Taking a step back for a second, can anyone explain to me the difference between a hypotenuse and a leg?
Hypotenuse is the longest side.
Good. Yep. And a leg is just either of the other two sides on the right triangle. And I know that it's a hypotenuse if it's across from the right angle. So as long as it's across from the right angle, I know I'm looking at the hypotenuse. All right. Does anyone have any questions? Is all sounding good so far?
Sounds good.
All right,
Yeah.
cool. People tend to have a hard time differentiating between like angle side angle and angle side. Typically the way I do it is I just kind of go around the triangle and I kind of like see like if I go from one part that's marked to the next, like do I see an angle and then another angle, or do I see an angle and then a side? It's like over here, if I'm going from one marked part to the next, I see an angle, and then the closest thing that's marked is a side, and the closest thing that's marked is an angle. But over here, I see an angle, and the closest thing that's marked to that is an angle. And then there I have a side. All right. But yeah, pretty much if we're trying to write a proof that involves congruent triangles, at some point, we're going to need to use one of these 5 theorems. So if you try to do one of these proofs and none of those theorems show up, you know that you need to go back and like take a look at what you did. All right. If anyone's taking notes, are y'all all good, or does anyone want me to hold on for a second?
Good.
Okay. Let's go. I'm going to go ahead and clear this in so I can go ahead and move on to the next set of notes. Okay. So typically, as y'all have probably seen in class, it's not enough to just know those theorems though, in order to get through these proofs and to get through, being able to work with congruent triangles. There are also some other important theorems that we need to know. For example, we have a theorem about vertical angles. Can someone tell me about vertical angles?
They congruent.
Yeah, exactly. What do they look like?
An X.
Yep, exactly. They're just two angles that are like across from each other. So they typically form like an X shape. And we know that they're always going to be congruent. So vertical angles are congruent. Okay. And then we also usually run into the reflexive property, which, what does the reflexive property tell us?
Like when two sides are like the same side, like there's one.
Perfect. Exactly. Basically, things are equal to themselves. So like if I had these two triangles right here, I know that the side in the middle is going to be congruent to itself. So I could use that potentially to help me prove that the two triangles are congruent. And then last but not least, we also need to think back to what we know about parallel lines. So parallel lines have a lot of different theorems in them. If y'all remember from either earlier this year, or you should have also covered it in middle school, but I know that was a while ago for a lot of y'all. So remember when we have two parallel lines that are intersecting, we have corresponding angles that we know are congruent. Let's see if I can stretch that out a little bit, maybe. Okay, and then we also know that alternate interior angles are congruent. And there are typically other like angles that we can say are congruent too, but corresponding and alternate interior are typically the two that show up most often when we're talking about congruent triangles. So just as a reminder, I'm going to go ahead and draw a couple sets of parallel lines. All right, and I'm going to give each of those numbers. Okay, can someone give me a pair of corresponding angles? Just as a reminder, corresponding angles are typically angles that are like in the same spot when I'm looking at both lines. It's like, for example, angle 1 and angle 5.
Angle 3 and angle 7.
There you go. Good job. Anyone else?
4 and 8.
Yep, good. 4 and 8 would be another pair. All right, and what's the last one we haven't mentioned yet?
2 and 6.
2 and 6, perfect. Okay. All right, what about alternate interior angles? If y'all remember, I like to call those the ones that make the Z with each other. So like, for example, angle 3 and angle 5. They're like still inside the parallel line, but they're on opposite sides of the line that cuts through it, that which we call a transversal. So I see one other pair of alternate interior angles. Does anyone else see it?
5 and
4 and 5.
Perfect. Good job. All right. So as we all know, that's the easy part. Like in theory, this isn't that bad, but it's kind of hard like when we start to put it into practice and start writing proofs for ourselves. So we're gonna warm up first by just reviewing like how we work with these congruence theorems, and then after we review that, we're going to we are going to go into actually writing proofs. Okay, so let's take a look at number 1 together. All right. So number 1's asking us to state if the two triangles are congruent, and if they are, state how you know. So the first thing I noticed, what type of triangles are those? Yeah, I think I heard someone say it. You said that they're right triangles, right?
Yep.
Yeah, they're right triangles. Okay, and then what congruence theorem typically goes with right triangles? I think I heard someone try to say it. Yeah, good. Hypotenuse lay. So if you look, we already have two sides of the right triangle marked. What are those two sides? Are those hypotenuses or legs?
Hypotenuse.
Yeah, good. They're both hypotenuses. All right. And then we also know by the reflexive property that this line in the middle is congruent to itself too, right? So then we can say that these two triangles are congruent by hypotenuse leg. Okay. So looking at number 2, again, it looks like I have two right triangles. And now I see two angles that are crossing each other. So what do we call two angles that are crossing each other again? Sorry, let me show you what.
Vertical angles.
Vertical angles. And what do I know about vertical angles?
They're congruent.
Right. So this angle right here is the right angle. What does the angle across from it have to be?
Also a right angle.
Perfect. Notice though that we're not going to use hypotenuse leg for this one because the two hypotenuses, we don't really know anything about them. We only know about the legs and the angle between them. So let's see, it's not on here because apparently I guess this is just for right triangles. But if we can't use hypotenuse leg, what theorem should we use to say that these two triangles are congruent?
SAS.
Sorry, one more time. I think someone said SAS.
Yeah.
All right, perfect. Yep, these two will be congruent by side angle side. Okay. Moving on. Number 3. What do y'all think?
Side angle.
Side angle side.
Perfect. Good job. All right, what about 4? Ignore what they have here. First of all, okay, so I only have a side and an angle, so that's not enough information. Is there any other part of these triangles that I can mark congruent?
Side.
Hypotenuse.
Yeah, good. I can mark the hypotenuse congruent to itself. Okay, so then what theorem could I use to say that these two triangles are congruent? Which in theory I shouldn't have put that because they actually do give us the answer there.
Hypotenuse leg.
There you go. Good job.
Why wouldn't it be side angle? Is there?
But going back, there's not a side angle theorem.
Oh, okay.
Yeah. If there was though, you're right, we could use that. But yeah, side angle isn't a congruence theorem, so we can't use that.
Okay.
Good question. All right, so what about number 5? It looks like I have some stuff that's marked. Is there anything else I can say besides what's marked in the picture? What about those two? What about the angle across from the right angle? Yeah, good, it's congruent. So I'm gonna have another right angle right here. Okay, so then what theorem can I use to say that these two right triangles are congruent? All right, let's go around the triangle. So right here I have an angle, and then another angle, and then a side. So they're congruent by angle, side. All right, we're just going to finish up the page, and then we're going to start talking about proofs. Okay, so what about number 6? Ignore these. Just use the 5 that we talked about today.
Say.
Sorry, one more time.
ASA.
Perfect. ASA. Okay, two more, then we'll move on. What about number 7? What are y'all thinking?
Side angle side.
Good. Yep, side angle side. Because I know that this right angle is congruent to this right angle. Okay, last one.
Side angle side.
Yep. I got two sides and an angle in between them. Okay, how's everyone feeling about those? Okay, cool. I'm gonna take that as good, and we're gonna go ahead and move on. Two proofs, which is the meat of what we're going to be talking about today, because they're pretty tricky. All right. So let's look at number 1 together. But before we start, let's see. I know that my Leesville students have only been doing flow proofs. They haven't been doing any 2-column proofs. What about at the other high schools? Are y'all more familiar with 2-column proofs or flow proofs?
I forget what proofs are.
Okay, that's fair. That's fair. Yeah, actually, let's take a step back and actually talk about like what actually is a proof in math before we even get into this. All right, so here I'm going to stop sharing. And I'm going to bring up another whiteboard. All right, so that's a good question. So what are proofs? Well, let's just take a step back and think about what that word means. Like, what does it mean to prove something in general? Okay. Basically, a proof is a logical argument or they're logical arguments based on certain premises that guide us to a certain conclusion. So guide us to certain conclusions. All right, but I know that right now y'all are thinking, what the heck is he talking about? Please say that again in English. And another way to think about it is basically just a step-by-step way of showing that something is true. We want to go from what we know to what we're trying to figure out. So before we even start talking about congruent triangles, what if I just had, I don't know, what if my given statement was, let's see, given, Mr. Julian has a degree in math. And we want to logically prove to someone that Mr. Julian knows how to write a proof. So if someone told me that, well, I would start by telling them, well, you know that I have a degree in math, right? That's my given. That's our given. We're always going to start with the given. From there, well, because I have a degree in math, that means that in order to do that, that means that Mr. Julian has math classes that involve proofs. And because I pass math classes that involve proofs, that means Mr. Julian knows how to write proof. So I just kind of step by step broke down like a logical argument that kind of like takes you from, what you know, that I have a degree in math, to what we're trying to figure out, like the fact that I know how to write a proof. So obviously this was a silly example. Clearly you won't be asked to do something similar to this in class, but let's take that kind of same idea and apply it to actual proofs with congruent triangles. Okay, so here I have number one. I'm given that BD is perpendicular to AB and BD is perpendicular to DE. And I also have that BC is congruent to DC. From that, I want to prove that angle A is congruent to angle E. Okay, so like I said, the first thing you always want to start with is your given. Before we get into the givens though, can someone tell me what perpendicular means? Like that little like upside down T?
Make like right triangles. Angles make right angles.
Yeah, I think I heard someone say that perpendicular lines make right angles, right?
Yeah.
Yep, so that's pretty much all we're saying. That because BD and AB are perpendicular, that means that we have a right angle right here. And we also have another right angle right here. Okay, so let's go ahead and start there and see if we can somehow get to proving that angle A is congruent to angle E. So BD is perpendicular to AB. I know that. Or it probably would be easier for me to just try to type most of this out. I'm gonna make the font a little smaller. All right, so that's one of the things I'm given, that BD is perpendicular to AB. Draw a box around it. And I'm also given that BD is perpendicular to DE. I'm gonna draw a box around that. And the last thing I'm given is that BC is congruent to DC. And I'm going to draw a box around that. If I could get it to show up. Okay. So these things that I've typed into the boxes are called my statements. They're basically what I can claim. And for each statement, I have to give a reason that I can say it. So at the start of a proof, my reason for all of these is just going to be given. It's given that these two sides are perpendicular. It's given that these two sides are perpendicular. And it's given that BC is congruent to DC. All right, like we stated before, perpendicular lines form right angles. Unfortunately, I know it's a lot of work, but in proofs, we can't take anything for granted. So I have to actually state that because BD is perpendicular to AB, can y'all see the drawing all right that I'm referring to?
Yes.
Okay. I have to state that angle B is a right angle. And because I know that BD is perpendicular to DE, I can't take any jumps in logic. I have to say that angle D is a right angle too. All right. And my reasons for that are by definition of perpendicular lines. The same reason for each box. All right. Again, for there, not taking anything for granted, I then need to state that triangle ABC is a right triangle. I'm just going to draw a picture of a right triangle. You all should actually write it down, though, if it's your homework. And I also know that triangle EDC is also a right triangle. All right. Does everyone follow me so far? Does anyone have any questions?
Nope.
Nope. Wait, did you say nope or you do?
I don't.
Okay, cool. All right. So, okay, so we know that both these triangles are right triangles, and we know that BC is congruent to DC. Which is marked in the picture. Actually, looking at the picture, I think that we can actually go a different route to prove this. Let's just go back and talk about it for a second. Because it doesn't look like we're going to use our hypotenuse leg here. Okay. So can anyone tell me, looking at this picture, I'll try to zoom in on it a little bit. What theorem could I use to prove that this triangle, these two triangles are congruent?
Angle, side angle.
Exactly. Yeah, so I see an angle and a side. Where are the other two angles coming from? Or I should say, what types of angles are the other two angles that you saw?
I saw the right angle, and then I saw the leg or the base or whatever, and then angle C.
Right. Yeah. What about angle C? Like, why can I say that this angle is congruent to this angle?
Because vertical angles are congruent.
Yes. There you go. Good job. So yeah, I'm actually not going to go the hypotenuse leg route for this problem. I'm going to go the angle side angle route to try and prove that these two triangles are congruent. Okay. So because I know that angle B is a right angle and angle D is a right angle, well, all right angles are congruent to each other, right? So I can say that angle B is perfect. Unlike my handwriting. I'm working on a touch screen. It's not as neat as if I was writing it down. And my reason for that is by definition of what a right angle is. Okay. So I know that angle B is congruent to angle D. I know that BC is congruent to DC. And I also know that because there are two angle C's, I have to differentiate them by, calling them by three letters. So I'm going to say the angle ACB, the angle on the top of my picture, is congruent to angle ECB, which is the angle on the bottom of my picture. Or sorry, not ACB, ACD, excuse me. And that one I know because vertical angles are congruent. Okay. Another thing that I want to point out, notice that I'm only drawing arrows between when I'm basically saying like, well, because I know this, I can say this. They're not just going to like random spots or like, they're not just like going to random spots in my proof. So like, I start off with stuff that I can just say just because of what I know about, geometry and also what I'm given. So like I know the vertical angles are congruent, so I don't have to attach that to any of the statements that were already given. What I said about perpendicular lines and angle B and angle D being congruent, though, that comes from my initial statement. Like I logically have to like take a couple steps before I get there. So that's why there are arrows pointing from BD is perpendicular to AB to angle B is the right angle, so that therefore we know that angle B is congruent to angle B. All right, so now I have all my pieces. So I'm just gonna go ahead and say that the two triangles are congruent. So triangle ABC is congruent to triangle EDC. And again, what's my reason for that? Go ahead and finish it off. Let me go, y'all. I think I heard someone trying to say it. Angle, side angle. Okay, so I know that's a lot of steps. Does anyone have any questions? We have plenty of time, so.
No.
Okay. Moving on, let's take a look at number 2. And this time, we're going to do what we should have done the first time. We're going to think about a strategy for this one together before we try to write a proof. So I'm going to zoom in a little bit and we can talk a little bit more about what's going on. Okay. So looking at this, oh, whoops, I almost forgot. In number 1, they were asking us to prove that angle E is congruent to angle E. So once we say the two triangles are congruent, and this is pretty much true for most proofs that are like this. Once I say that triangle ABC is congruent to triangle EDC, and once again, I can say that because of angle side angle. Saying that angle A is congruent to angle E is the next step. Because corresponding parts of congruent triangles are congruent. All right. Basically, which basically is just a math way of saying like matching parts of two triangles that are supposed to be the same are also going to be the same. So here, if I'm looking at number 1, I know that angle A is going to be congruent to angle E. Can anyone give me any examples of any other corresponding parts? What about side AB? What would correspond with that? Like, what would be the matching part in the other triangle? Side ED. I could also have side BC, which I know is going to correspond with the side that's across the side DC. And so on and so forth. But basically, matching parts of matching triangles have to be congruent. Okay, so with that in mind, let's go ahead and think about a strategy for the proof for number 2. Okay, so looking at these two triangles, Who can tell me how they might be how we might be able to prove that they're congruent?
Side angle side.
Yeah, good job, Suhani. So I have the two sides. Where are you getting the pair of angles from?
The vertical angles.
Good. Yep. I have that set pair of. Well, let me try to get that out of here first. The early technology sometimes. Okay. But yeah, I have this pair of vertical angles. So this is actually a pretty straightforward proof. Like pretty much all I have to say is my given statements and that vertical angles are congruent. And then from there, I can pretty much just say the two triangles are congruent by side angle side. Kind of weird. I wonder why they didn't start us off with this one. But anyways, let's go ahead and formally write that up. So once again, I'm always going to start with my given statements. So I'm given that BC and DC are congruent. That's just, I got that one for free. And I'm given that AC and EC are congruent. Again, that's just given to me for free. I don't have to do any work. It's just stated right there in the problem. We also know that angle BCA is congruent to angle DCE.
Sorry.
Of course. Because vertical angles are congruent. And using those three statements together, I can say that triangle BCA is congruent to triangle DCE by side angle side. All right, does anyone have any questions about that proof?
No.
Nope.
All right, cool. All right, so for this next one, partially because I'm kind of tired of hearing myself talk, and also because I need to get water, and also because I want to make sure that y'all are still awake. I want you all to give number 3 a shot. So I'm going to give everyone 5 minutes. We'll come back at 7:10 after I get my water, and I want to see what everyone's thinking for number 3. Okay. All right. So let me go ahead and zoom in on it so y'all can see it a little bit better. All right, go ahead and give it a shot. I'll be right back. Okay, I'm back. Let's go ahead and talk about it. All right. So looking at this proof, I'm given that YA is congruent to BA and that angle B is congruent to angle Y. And from there, I want to prove that AZ is congruent to AC. Okay. So what's my strategy here? Remember, the first thing I want to do is prove that the triangles are congruent. So how can I prove that?
You can prove it by angle, side, angle.
Perfect. And then after I prove that the two triangles are congruent by angle, side, angle, whoops, thought I had my draw tool on. Okay, there we go. So after I prove that they're congruent by angle, side, angle, how can I then go from there to saying that AZ is congruent to AC?
Say that again.
So once I say prove that the triangles are congruent, how can I prove that AZ is congruent to AC?
Mm.
I'll give you a hint. It's a 5-letter acronym.
OCP.
Yeah.
Yep, corresponding parts of congruent triangles are congruent because AZ and AC would be corresponding parts of those two triangles. So basically all we're doing is from the given, and also because we know that we have a pair of vertical angles there, we can go from there to saying that the two triangles are congruent by angle, side, angle. And then from there, I can say that AZ is congruent to AC because corresponding parts of congruent triangles are congruent. All right, let's go ahead and formally write this up now. Okay, so whenever I'm writing a proof, what's the first thing I always want to state? Anybody?
The given.
Right, I always want to state my givens. So in this case, my givens are that YA is congruent to BA. I'm going to start that up higher so I can. My givens are that YA is congruent to BA. And that angle B is congruent to angle Y. And I know both of those because that's given to me. Okay, so does anyone remember from our strategy, what's the next thing that we want to say? Or I should say, what else can we say in addition to what we're given? Are there any other parts of the triangle that I can like say are congruent to each other?
The vertical angle.
Yeah, good. I can say the two vertical angles are congruent. So I'm going to say also that angle YAZ is congruent to triangle BAC. Because I know that vertical angles are congruent. All right, and then where did I go from there? Do I have enough information to say the triangles are congruent, or do I need to say anything else? think I'm good. I can just go ahead and say the triangles are congruent now. And that's by angle side angle. And then by CPCTC, I can say that AZ is congruent to AC. That's by CPCTC. Okay, that's all there is to it. All right. Any other questions?
Nope.
No.
All right, cool. Let's go ahead and clear all that out then. All right, so number 4 is a little bit different. Remember I warned you that we're probably gonna have to deal with parallel lines at some point. Okay. So looking here, we know that WX and YZ, the two sides on the top and bottom, are parallel to each other. And I also know that WX is congruent to YZ. Using just that information, they want us to prove that triangle WXZ is congruent to triangle YZX. Okay, so let's think about a strategy here. Does anyone see how we can prove that the two triangles are congruent? Or any thoughts on like information that we can use to help us?
There's a shared side.
Good, yeah, they both share that side ZX, right? So I can say that ZX is congruent to ZX by the reflexive property. Okay, what else? Remember, we haven't used the fact that the two lines are parallel yet. So remember I said that there are two types of angles that we can say are congruent looking at parallel lines. It's corresponding angles and alternate interior angles. Do we have either of those in this picture?
Yes.
Yeah, where are they?
You.
It looks like I have a pair of alternate interior angles here and here, because they're like the angles that make the Z with each other, right? Okay. So I can say that those two angles are congruent because they're alternate interior angles. I can say that this side is congruent to itself by the reflexive property. And they already gave me that the top and bottom sides are congruent. So what theorem then could I use to prove that those two triangles are congruent to each other?
Side angle side.
Perfect. All right, so putting it together. I know that I have my given statements. I know that alternate interior angles are congruent. And I have my side that's congruent to itself by the reflexive property. And I can use all of that because we use the fact that the two lines are parallel to prove that we have alternate interior angles. That's why I have the arrow from given to alternate interior too. So from there we can prove that these two angles these two triangles are congruent by side and side. All right, let's go ahead and formally write it up. And then after that, we should probably call it a night.
Sounds good.
Okay. So I'm going to start with my givens that WX is parallel to YZ. And also that WX is congruent to YZ. All right, so then from there, because I know that the WX is parallel to YZ, I can say that those two alternate interior angles are congruent. So the angle WXZ is congruent to angle YZX. All right, and then I also know that ZX is congruent to itself. By the reflexive property. All right, so then I can use the fact that this side is congruent to itself. That those two sides are congruent. They're two different sides. They're not the same side. That this side is congruent to itself, though, and that this angle is these two angles are congruent to themselves. To say that the two triangles are congruent to themselves by the side angle side. All right, any questions on that last one?
No.
Okay.
No.
All right, I'm gonna go ahead and stop sharing if I could. There we go. Okay, so that about wraps up this talk. The last thing, if anybody wanted to take a look at this anymore, and work with this with your center tutors in session, feel free to, just let them know. And you're also welcome to download those files to take a look at if y'all want to look at this further. If everyone could go to the chat, that's where the folder is that has all the congruent triangle practice in it.
Thanks.
Yep, no problem. So until next time, I'll see y'all later.